Hi, in this series we're looking at the wonderful world of compute shaders. A quick way of getting a more interesting background in a 2D project than a solid colour is by using a vertical gradient like this. We're going to use a shader to create a 2-colour vertical gradient, and at the end we'll have a little bonus and we'll animate it to create a day-night cycle. Let's get started. The first thing we'll do is create a quad that we'll apply our gradient to. Right click, select 3D object and quad. The standard orthographic camera is 5 units, so we'll scale this up to 10 in Y so it fills the vertical, then choose something large like 25 for X, so it will cater for several aspect ratios. Parent the quad to the camera so it follows it around and gives you that constant background. Currently, it's just using some default lit material, so let's create our shader. Right click, create, shader, unlit shader. We'll call this vertical gradient. Right click on the shader and select create material. This creates a material from our shader. Drag it onto the quad to assign it. Let's get started on the shader code. Firstly, we don't need anything to do with textures. We're going to create the gradient entirely in shader code. So we'll delete main text and we'll add 2 color properties. First is the top color for the gradient, which will default to white, and the second is the bottom color, which will default to black. As we're using this for a static background in a 2D application, we can simplify this shader. We'll remove the fog related code as we go through, so we can get rid of the multi-compile fog line. We don't need to change anything in our app data structure. We're going to use the UV coordinates to do our gradient for us. In our V2F structure, we're going to make one slight change to the UV output. Instead of it being a float to UV, we'll change this to a float for called color, and that's what it will represent. Again, we remove the fog code from here as we don't need that. Now before our vertex function, we have the 2 variables for using the texture. We can remove them and add in the 2 variables we do need for the colors. That's a fixed for top color and a fixed for bottom color. If you've not come across fixed for before, you can think of fixed for as a really low precision float. It can only take values in the range -2 to +2 and has a granularity of 1/256th, which makes it perfect for colors. In the vertex function, we keep the mapping of the object vertices with Unity object to clip pos and remove the texture and fog components. In their place, we're going to assign our color element of the V2F struct we added earlier. So how are we going to do this to create our gradient? We need a quick recap on how UV coordinates work. The UV maps the texture onto a square where the bottom left is 0, 0, moving to 1, 1 in the top right. This is exactly how it'll look on our quad. So when the Y coordinate of the UV is 1, we're at the top row of our quad, and when it's at 0, we're at the bottom. So what we do here for the colour is to linearly interpolate with the lerp function between the bottom colour and the top colour using the uv.y coordinate. Note, I'm going from bottom to top because the UV-Y coordinate is 0 at the bottom and 1 at the top, else our gradient will be upside down. In our quad, there are only 4 vertices, but this will also work for shapes with more vertices, and it'll assign the correct colour at each one using the lerp. Finally, in our fragment shader, we can simplify this right down by deleting everything here, then simply returning i.color. Because we've correctly assigned the gradient color to each vertex, it will get linearly interpolated for us for each pixel. That's it. Let's dive back into Unity and see this in action. You can see already that we've got the default white to black gradient on there. I'll just switch to game view so you can see it more easily. And we can change the colors on our material to get any sort of effect you like. I quite like this black to orange color as it reminds me of that cool dusk glow you get. You could take this one step further and animate the gradient like this to create something akin to a very basic day-night cycle. For this, I've just created a simple script which I'll run through very quickly. First, we have a reference to the material we want to update and the time we want the effect to take. Then we have our 3 pairs of colours which define the gradient transitions: start, middle, and end. In the update function, we calculate the elapsed time since we started, taking this mod the effect duration so it repeats. There will be 4 transitions as we'll go forward and backwards, so we calculate our percent over a quarter of the elapsed time. Then, for For the first quarter of the elapsed time, we calculate our colours by lerping between our start and middle colours using colour.lerp and our percent. For the next one, it's middle to end, then back from end to middle, and finally from middle back to start. We can then update our material using the setColor method and passing in the variable names we assigned in the shader. That's all there is to it. I hope you found this tutorial useful in some way. As ever, the code is available on GitHub and is linked in the description below. See you next time.